today's topics: building envelope theory. Sam will talk to us about that. Envelope diagnosis and analysis. We'll look at things like thermography, but also building simulation. Then we'll turn our attention to the areas of opportunity, the practical wins, and the strategic investments. And finally, we'll touch on implementation considerations. Why good envelopes matter, right? Well, I mean, I think the right-hand side, and actually I'll have an example that goes beyond that, but 35 to 40% of heating, cooling, energy use is lost or gained through the building envelope. So it's a major component of any building's energy consumption, right?
The purpose of the building envelope, much like the clothing, is keeping the outside out and the inside in. And ultimately, this is the sort of fundamentals of what we're trying to get at. The R value, the insulated value here, thermal resistance, R is for resistance, will vary depending on the type of envelope component that we have. That said, and you see at the bottom of the slide here, as things move progressively further to the right, things tend to get a bit more expensive as well. You know, when we're thinking about improving envelope from an energy perspective, we often tend to gravitate towards this thermal resistance layer. What is it that we can do to increase the overall R value of the wall? Add more insulation. That's going to solve a lot of problems. And in many ways, it will help and it will solve a lot of problems. It will improve that thermal resistance. But we cannot forget about these other layers.
Red screen can be applied in many, many different situations, both energy efficient, renewable and energy efficient technology screening software. So not just in renewables today. Many people have seen red screen in the past as a renewable. No, it's actually also an energy efficiency tool as well. The building envelope model allows you to model all the different elements of the envelope itself, the walls, the windows, the doors, the solar shading, all those kinds of things. With this tool, all I want you to take away from this, with this tool, right, you can determine the R value. A lot of people say to me, what's the R value of that wall? You can't measure it very easily, but you can actually, if you can identify from a drawing, a sketch, you know, what's in it, you can use a tool like this to figure this out.
There's a lot of great tools out there that we can use to diagnose what's going on with our envelope. We don't really see it. We don't see heat transfer. We don't see the air coming in and out. Thermal imaging, we've already started talking about this a little bit, is a really cost-effective tool to gain insights into what the naked eye cannot see.
The other thing too to think about is we talk about air tightness. One of the greatest opportunities in many cases when you replace a window is to actually improve the air tightness of how the window integrates to the building structure itself, right? You know that yourself maybe in your home. Same thing in a commercial building.
Really good case study here, a building in Vancouver where they went from R4 to R16 through exterior cladding, and 90% reduction in suite heating load. This is a residential building, an apartment building, and 20% reduction in overall building energy use. So we do need to think about the sort of life cycle impact of the carbon associated with these retrofits. Climate resilience, another aspect we need to think about our envelope as Stephen said at the beginning. It's a kind of envelope is our first line of defense when it comes to weather, and the weather's changing. And so, you know, if we're designing envelope retrofits now, certainly designing new buildings, we want to make sure that we're designing them for the future, not for now. And so we want to make sure that in 50, 60, 100 years time, they're still going to be able to withstand what's occurring in terms of climate, not just temperature.